And welcome to the desk of Ladyada, where we try to find the best obtainable version of the truth, and we do some engineering. Ladyada, hello.
It's true.
We also try to find MOSFET.
Well, he was bugging me.
MOSFET is the
This
truth.
is his punishment.
Yeah?
Yes, say hello.
Yeah. He was
Hello.
hiding behind the green screen.
Hello. Okay, he wants
Yeah.
to go. Later, dude.
Bye, cat.
He's like, I want attention, but not that kind of attention.
What are you doing tonight?
Well, tonight, first off, we had a lovely day. We went for a long walk. We had some tasty oysters. But now we're home.
Yeah.
And I got like kind of those leg cramps you get when you walk a lot. And so
We walked all the way up to 50. We walked from like Lower Manhattan to Central Park and back.
yeah, basically from Adafruit,
Yeah.
Soho, all the way up
Yeah.
to 60th and back, and we walked around back and forth a little
Yeah.
bit.
It was a day.
It was a day. It was a beautiful day. Perfect walking weather. And then while we were walking, I was talking about these great chips from Nordic, the NRF52.
That's how we design electronics. Ladyada just talks to me about chips and electronics, and then she asks me some design questions or some ideas or whatever, and then at the end of like a 4-hour walk, we usually crash out, and then she emerges, and now it is time to witness the Feather,
Birth of Tronics.
Metro, Nordic, Eagle,
All these words.
Blur.
All of
yeah,
them.
that's what's gonna happen now.
Yeah, so the Feather NRF52 is a K-Town design. K-Town is the master of wireless, master of Bluetooth. He even wrote the book on Bluetooth. We carry it. I'll bring it up just because it's so cool that he even... Yeah, see? Getting Started with Bluetooth Energy by K-Town. And also Akiba and Charles Kufi and Robert Davidson. Also awesome people, but K-Town is K-Town. Anyways, he's the master of Bluetooth, and he designed this board to show off the latest and greatest chipset from Nordic, the NRF52 832. And this chipset is an upgrade from the NRF51, which is what we've used historically with our BLUEFRUIT modules. And what's cool about the NRF52 is it's got a ton more flash, a ton more RAM. It can do central mode. It just has so much more of everything. The NRF51, it's a good chip. It's used in a lot of things, but the NRF52 is just like that much better. I'm trying to remember the stats on the 52. Okay, so the 52 has 512K of flash compared to I think like 128 maybe on the NRF51, 64K of RAM. I remember when the NRF51 first came out, I think it had 16, and then they upgraded to 32. So this is already 4 times more than the original 51. Bluetooth Low Energy, and it has enough space that it can do central mode or peripheral mode, so you can use it in both, which is cool. It's a great chip, and it has an Arduino core for it that Sandeep Mystery wrote. And great core, so you can use this Feather board that we designed as an Arduino compatible. Basically just add our board support library and you're rocking. And what's nice is that because this chip has so much capability on its own, you can have the soft device, the software radio, and all this other space for your software, like your firmware that you write. You don't need an extra coprocessor to help you along. So, for example, let's look at the overhead real fast, and I'll compare the two. So up top is a board that uses our NRF51 modules. This is a red module. We get our modules from Raytac. They seem to be a pretty good supplier of modules, and they're FCC C-Talix certified. So what's really nice is that, you know, people know that this is a well-designed radio. If they do want to use it in a product, it makes their certification faster. But for this module, just the way that we ended up using it, it didn't make sense to have it run on its own. Instead, it's controlled by this Atmega 32U4. We also have one with the ATSAMD21. But this is the chip that you program through USB, and you get analog and digital outputs that way, and then this communicates with this chip through SPI. So that's all well and good, but you do have these two chips now. Instead of just having one inside, you know, there's a chip inside of here and a chip inside of here. You just added cost, you added complexity, you know, less is better. So the NRF52 here, there is no coprocessor. This is just a debug connector. This chip inside of here not only does the Bluetooth radio for you, but it also has analog, PWMs, timers, SPI, I2C. It's a really nice solid chip, and again, you can use it directly using a bootloader with a USB to serial converter chip, which is really not a big deal. Those are very, very low cost and very easy to get. We use the CP2104. So altogether, what this means is you have a you know, less expensive, less complicated, more powerful setup here. And so we made our first batch, and it like sold out like really, really fast. People really dig it. We're making more. There's a lot of signups. And because this is popular, I was like, well, you know, maybe let's, you know, if I see something that's working out, I'm like, well, let's make more of that thing that's working out. So maybe let's make a Metro-shaped version. So that's what I was thinking while we're on this walk.
Okay, could you repeat the name of the supplier of the modules?
Yeah, it's Raytac. Like Ray and then Tac.
Okay.
I think we have the data sheet linked in the product pages. You just, you know, go to the tutorial. So the Metro design. Okay, so let's go to the computer. Hello. Can you switch me to the computer?
Yeah, I was
Sorry.
kind of stuff.
Thanks. So the Metro design that I'm going to be using is basically this, right? You've got your Arduino shape compatible, USB, some status LEDs, on-off switch, DC jack, and then you know SPI port and the standard I/O header. So the idea is just to take the feather. Let me open up that page. Take the feather design and then just grow it into the Metro design. So that's what I'm going to be doing tonight. Hopefully fun. And because the feather design is like well established, it's easy for me. I just copy and paste the schematic in, and then maybe tomorrow I'll route it up. So let's go to the folder of dev boards, and I'm going to take my, I'm going to make a new folder. And this is going to be called Metro BLUEFRUit NRF52. And then I'm going to take my Metro design, and actually recently made a version with the CP2104, which is going to be in stock soon. So I'm going to use that as my basis, and then I'll just rename this. All right, I'm just going to be doing computer stuff for a bit, so
Yep.
you can just hang out. Let me drive. Okay, so I'm going to clean this up. So this CP2104 should actually be like down here. Okay, so this is the Metro design I'm going to be recycling a bunch of. I'm going to keep the reset button and the GPIO pins and the SPI pins. Like most of it I'm actually going to keep. What I'm going to change is and it's one of the things we chatted about, is instead of a DC connector, we decided, well, you know, there's a pretty good chance that instead of plugging into a DC power supply, people are going to use this with a LiPo battery, because Bluetooth, it's probably going to be portable or embedded in something, or wirelessly controlled. So let's replace the DC jack with a LiPo charger instead. And we'll end up gutting a bunch of this stuff here. So, and we'll just, you know, the silk screen will change, of course, but for now we'll just leave it as is. So we're not going to change anything here yet, but let's create a new sheet, which I actually don't usually do. Usually I just copy paste, but I want to keep it organized. So then we'll go to our feather. It's called Minute BLE because we originally designed it with Minute, and this is the feather design. And what we'll do is we'll just grab all this, and we'll just delete what we don't need. So grab this, paste it here. Okay, so what do we need? Well, we're going to keep the LiPo charging, so that's good. We're not going to use this USB connector, because we already have a USB connector, so we'll go to this. Bonk. And then USB TTL bridge, we're actually going to reuse the one that's on the Metro already. So let me just check the connections. So this is VIO VDD reg in to 3.3 volts. Yeah. V bus, VPP, D minus, D plus, RX LED. So the only thing is I have to add this resistor. And then I use DTR, that's being used. So I'll tell you what I'll do. I'll actually move, well, I'm going to rename all of these things. But let's start with just adding a resistor here. Oh, you know what? There's a resistor here, that's why. So it's on the RX line. And I'll make this RXD. Okay, so I can delete this because it's duplicate. We also don't need the feather pinout because we're not going to be using it. We want to keep the SW connector, and all these other connectors are good too. LiPo charging and LiPo monitoring I'm probably going to keep. And then I'll keep this power supply for now also. So let's go to the board layout. Okay, so I actually have to get rid of some stuff. So I'm going to get rid of the 5.0 regulator and all this 5.0 regulator stuff because it's not going to be used. I'm going to get rid of this chip as well. So let's go here. I'm going to get rid of this 5-volt power supply. But what I'm going to do is I'm going to keep this switch in the same location, and I'm going to keep the DC jack. And then this I'm going to delete because it's duplicated. There's no IO level selections, so I'll get rid of this. Keep the LEDs. And let's look again. Oh, I want to get rid of this chip. I want to keep all these GPIOs, but I don't need this. I don't need any of this stuff either. Bam. I'll keep the reset button though. And then, oh, you know what, here this is, I have to remember, I always get this mixed up which way the RX and TX resistors go, but I'll just delete them for now. Okay, looks good. So next step, I'm going to just rip this all up. That's good. And I don't need this thing. Okay, so now we've got most of it cleared out. You know, not all these parts are going to get kept either. Like, for example, I don't need this op-amp section either. That's for the selecting between the DC power jack and USB. I'm not going to use that because with the LiPo, it's always going to be less than the USB power. So I'm just delete these. Okay, even better. So this is like super cleared out. All right, so now here's all the extra stuff that we need to place. So not too bad. Let's get that over there. Let's, we're gonna do, the module last, but let's put in the connector for the battery. Let's turn off some layers that are confusing. I'll leave this layer on, we'll get rid of it soon. So the DC jack was here, and I'm just gonna like place the battery connector like right where the DC jack is, just like exactly that way. And the reason I'm doing this is so like if you have like an enclosure or something, it makes it an easy swap because the hole is in the same location. And then now that that's placed, I'm going to delete these things. Later. And then I'm keeping the switch, but I'm going to delete everything else. And then, oh, I don't need this either. This is the level shifting for the FTDI chip or the CP2104, but don't need this anymore. Okay, and then I've got the CP2104 here, and I want to get rid of it. That's weird, why? Looks like the CP2104 is not deleted. This is U8. Let's find what U8 is. Oh, it's the thermal pad. Sometimes if you have like remainder parts, like if a part is made of like 2 symbolic symbols, you have to delete all of them. So delete that. Okay, so now we don't have that extra CP2104. We only have this original one. That's nice. I don't have to reroute it. I know this layout works. It's all good. I don't need all of these anymore because I'm not going to do this like crazy thermal stuff for high current DC jack. And then I'll change this to be, probably like the switch. Like right now it says DC jack on it. This was the on-off switch for the DC jack. Instead, I'll make it for like just powering it on or off. I'll probably connect it to the enable for the regulator. So I'll leave that here and then I'll figure out what I want to connect it to later. Okay, so next up I've got this. So the only thing is it's a little, like not sad, but it's like, okay, I gotta think about it, is where do I want to put the module? I think I kind of want to put it like here. It's a little bit encroaching on the analog in text, but I mean, I don't want to put it here. Like I want to put it near the edge because I want the antenna to stick out. But if I put it here, it's kind of in the way of this mounting hole to the left, so that's not so good. And I could just put it in the center, but I don't really want to do that either because again, I want to have the antenna near the edge. Because I might be able to get a module that has like an antenna connector, so like that would be kind of useful. So right now, like my best bet is like kind of up here. Now the silk screen has like an Adafruit logo here, but I can remove that. So maybe I'll just stick it here for now. I'll get rid of these FCC CEs for now. Okay, so that's probably an okay place for it to stick around. Next up, there's going to be a SWD connector. That doesn't really matter where it goes. So actually I'll place that later. Let's see what else we've got in that second sheet. Okay, so we've got the crystal, we got a DFU button, which I don't know if I'll need. I've got the power regulator, and I think I deleted all that stuff from here. Yeah, this is USB VCC, so that's my USB power. There's a fuse, I'll keep the fuse. D plus is D minus, D plus goes to here, so that's good. USB VCC. USB VCC is going to connect, actually, you know what, I can name it VBus, and then that would like all match up here. And then this does like a nice switch for me. So let's rename VUSB to VBus. So let's go here. And let's change every segment to VBus. Great. And then I'll even add the symbol. K-Town likes to have like a symbol for each power supply, which like I'm down with that.
It's gonna be Metro Express BLUEFRUit.
No, it's gonna be like a Metro BLUEFRUit.
Metro BLUEFRUit, okay.
Yeah, it's not gonna be Express because I'm gonna wait until the NRF52 840 to make it Express, you know, like Circuit Python compatible, because we kind of want that. We want that native USB control. Alright, so let's put these LEDs here. So that's good. VBus, D minus, D plus, it's all good. So there's going to be a couple disconnected things, but basically VBAT goes in here. I'll probably keep the LiPo monitoring, but what I want to do is I have to remap all the pins because the Feather doesn't have that many GPIO, but the Metro does. The Metro actually has a ton of GPIO. Now, here's some good news about the NRF 52 832, and that is, actually now that I've reduced this down quite a bit, I'm going to move it over. Oh, I don't need this reset button because I have that nice big one. And then I have this DTR. Hold on. Cut this out. Actually, can I move this to another sheet? I don't know. What happens? Did it just make two? It made two. No. It did. Yeah, it made two. Damn it. I don't know if there's a way to like move an item from one sheet to the other. And then I'll just take the rest of this. Let's go. Okay, I'll clean up the schematic later. Which is like means never. I'll never clean it up. Got everything. Great. Delete. Okay, at least everything's on one sheet now. Got that switch over here. Let's see, let's put the power supply. Actually, move. Put the power supply here. Put the LiPo. Here, LiPo charging. Oh man, there's like no space here, and LiPo monitoring here. USB reset goes in this little box, and I can delete this stuff. This stuff. Move that up there. Alright. At least it's all on one sheet now. Easier to look at. Okay, sorry. So the Feather has a limited number of GPIO. It has like, I think, like 15 or something, 17 GPIO. Whereas an Arduino actually has a lot more. It has 0 through 13 digital, so it's 14 total pins, plus 3 SPI pins, plus 2 I2C pins, plus 6 analog pins, And then I'm also going to need one LED for a BLUEFRUIT Bluetooth signal. I like to have one extra blue LED for like blue LED signaling to let you know that's connected or paired. And I may or may not need this DFU pad. I'm not sure about it. But I do need to separate the SDWIO and SDW clock and maybe SDO. I might actually recycle this. So let's see how many pads we've got. So what we need is, max is what, the 14 digital plus 6 analog plus 2 I2C plus 3 SPI. So 25 GPIO, which is a lot. Now I can get away with less. Like the Arduino Uno actually doesn't have 25 GPIO. Instead, you have the 14 digital IO plus, well, not 60. 14 plus 6 only has 20 because the SPI and the I2C are multiplexed with the digital IO. So like digital 10, 11, 12, 13 are also SPI, and analog 4 and 5 are also I2C. But I prefer not to do that. If I can, I like to have them separate because it means there's like no risk of pin collision. So ideally, I get 25, but I absolutely need 20. Like if I don't even have 20, I'm kind of sunk. So let's see how many we've got here. Now remember, some of these pins are taken unavailable. So, one good thing is, other than the analog pins, you can multiplex the pins on the NRF52 pretty much completely. So I think the last I checked, I don't remember, other than the ones that are marked like, reset or SWD, IO, or clock for debug, you can, and the NFC antenna also is fixed, has to be P9 and P10. Other than that, and the crystal, these 2 pins for the crystal. But other than that, you can multiplex the pins to whatever you want, I think. So you've got these 1, 2, 3, 4, 5, 6, 7. So 7 pins. Okay, and then this is power supply pin, power supply pin, power supply pin. These 2 pads, crystal 1, crystal 2, can't use those. I'm going to use this for crystal. So 1, 2, 3, 4, 5, 6, 7. I think I'll keep the NFC pins alone, but that's 2 that if I absolutely need them, I can have them. So that's 7. So plus another 7. Okay, 14, getting there. And then up here I've got 1, 2, 3, 4, 5, 6, 7. I'm going to assume that I'm going to use the SWO pin, not for debugging, but for GPIO. Because you can always grab it if you need it. So sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. DFU, I'm going to use it, 10. And there's these pins I need. So plus 10. All right, 24. So, if I don't have the factory reset, that gives me 25. Kind of close. I did want to have that 1 extra pin for the Bluetooth LED because I would like that to be separate. So, there's no way for the user to interfere with that. So, basically I have a choice. I don't have enough right now for that full, beautiful contingent of 25. So what I can do is use the NFC pins. You can use them as GPIO. Or I can multiplex the SPI pins or the I2C pins. Not sure how I'm feeling about these. I mean, this is, like the Sophie's Choice of GPIOs. Right now, I'm kind of leaning towards multiplexing the SPI pins because on the Uno, pin 11, 12, 13 are multiplexed for SPI. And analog 4 and 5 are for analog. And like that, the 4 or 5 for analog really sucks because you're losing analog pins. So I don't want to do that. SPI, people do use it, but I think I'm more comfortable losing the 3 SPI pins and multiplexing them than I2C. Mostly because SPI doesn't have as many weird requirements as I2C does. So I think what I'll do is I'll probably multiplex those pins, keep the I2C pins separate, and that'll give me 2 extra pins, and that'll give me the because now I only need 25 minus 3, 22 pins. I have 24 available. They'll give me one blue LED, and it will give me maybe one DFU pin. Hopefully I didn't count reset. I don't think I did. So I think that's my plan. So I'll have a factory reset pin, and I'll have one factory reset pin. I'll have one blue LED pin. I think that's what I want to do, because I don't want to lose my crystal. It's another thing, you can lose the crystal. You don't get low power. A lot of trade-offs here, but I think that's my current plan. Any questions or?
No, keep
Great,
going.
I'm gonna keep going. Okay, so now I actually have to start like arranging the pins, and this will probably change as I do more development. But basically, you know, well, I'm gonna rename this. For example, this should be AD4, and this is gonna be AD5, and this is gonna be IO10. And then if I do multiplex SPI, that means it's going to be 11, 12, 13, so I'll keep that there. This will be SDA.
Are you exposing more or less pins compared to the feather version?
I'm exposing way more pins, but not as many pins as like the Metro M0 Express. The Metro M0 Express is just like, it has like pins galore. There's tons and tons of pins. It's a 48 pin package, and I get to use like basically 40 of them for GPIOs. Maybe 36 of them, so I've got plenty. This one, it just doesn't have as many pins. The NRF52 just doesn't have as many. So, oh, here's another thing I gotta change. Like for example, this IO has to be 3.3, and this 5-volt pin doesn't exist. I'm gonna make this be that. And I'll clean up all this stuff later. What I like to do is, I run ERC error, and it tells me like, hey, here's like all the places where you screwed up. So, so for example, the power LED, this is not going to be 5 volt, this is going to be powered from 3 volts. And now I actually have to, it's going to, you know, it's complaining basically like all of your pins aren't connected. It's like, I know, I got to connect the pins. So again, it doesn't matter what pins I use, they're all available. I can use any pins I want, and then in the variant, it's where I set them. So let's go to the board, and then I'm going to put this back here, ish, kinda. And I lost this. I'll fix it later, but it was kind of around here. I'll measure the DC jack later. It's kind of the. Wish I knew how to merge schematic sheets. The crystal has to be placed, you know, that's not changeable. I'm going to change the package though. I have another better crystal. So let me see if I have it. Extal. It's the crystal. Let's see, it's this one. Cheaper. Not better, but is cheaper. Okay, so, and I got put back down here. And this isn't like super essential, but I like placing the parts that have to be in a certain place first. And then I, you know, given that I can move around all the pads later, because again, they can be multiplexed. I'm going to go, oh, you know what, did I forget the, oh yeah, wait, I forgot, I have the PO 23 and 24 pads. I forgot about those, because I don't use them in the feather, but these are available too, so maybe I don't have to multiplex anything. We'll see. They're kind of hidden, but they're right here. They're kind of gross, you can like maybe I'll via them out. All right, so this is the crystal, and then I need the other capacitor for the crystal. It's kind of nice. And then this can go anywhere. And the rest of these parts are like, they're kind of all power supplies, so Not worried about them. None of them are essential. They can pretty much go anywhere. All right, so now it's time to actually start routing the pins. So let's, first off, let's get this ground plane back here a bit. Let's move that back. Let's move this back too. Now, it's not ideal. I wish I didn't have this SPI connector here, but that's life. And actually, you know, I don't like routing with a ground plane, so I'm going to just move this out of the way for now. And I'm not going to route all the pins again. I'm just going to like sketch it all out, and then I'll do the routing later. So let's turn off this bitmap. Actually, I'll leave TDocu on. That's kind of nice. And what's neat is because again, I can multiplex pretty much all the pins. I'll just do the ones that I can't multiplex first, which is the analog pins. And then I'll just make the digital pins be like straight shots, you know, to wherever I want to put them. So let's check out the analog pins. Those can't be, I mean, there's quite a few of them, but they're fairly fixed about where they can be. So this is, and you know, this is graphically equivalent. This is what it actually looks like. So even though this is called AN4 and AN5 and AN6 and AN7, it's not, that's not like literally the pins. They can actually be anything. But let's see. These are on the ends here. There's no analog pins on the right side. So maybe I can kind of swoop these around, or I can just go underneath. Let me just start by setting this up. Maybe I'll set this one to A5. Actually, what is this called? AN5? AD5. And that's this one. Okay. Oh, it's not too bad. This is 84, 83, 82, and then I'll grab 81, 80. Okay, so these kind of go around. Not too bad. The thing is, you know, I could put the module up here. It's kind of weird, but I could do it. Wouldn't be too bad. I'm gonna decide that tomorrow. Okay, so those are done, so that's good. Next up, let's do the I2C pins, because those are like over here. They're sort of far away, but they're also kind of near the ends here. So these curve around. These are analog pins. I don't want to multiplex the analog pins with I2C if I can help it. However, I am okay with maybe making these 3 pins, the I2C pins, as the SPI pins because they're so close to the SPI connector. So let's just sort of try that out. Get this to be S-clock, MOSI, and MISO. And we'll just call this AD6 for now, and AD7. I like to make sure that those pads are not used with some, like they're not connected to I2C or SPI or anything, so they could be used at the same time, because analog pins are great. So I've got extra pins now, but that's fine. And then next up, we just have to connect these pads up here. So the good news is we have a lot of pins. I'm gonna have to like do like really funky, because there's just so many of these, like all of these pins over here. Actually, did I get this? Oh no, those are the extras. So these, all these pads here are the GPIO. These are all going to fan up to here, like one after the other. So I might as well make it as easy as possible, where it's like, you know, 0 is 0 and like 1 is 1. So this, these 2 pads can be 0 and 1. So this is, they're called IO0. What's nice is as I select this pad to rename, it highlights the pin down here. It's kind of nice. So this is going to be IO1. This is IO0. And of course I'll check that, like I'm using these for UART connections. I'm going to make sure, of course, that there's no reason that these can't be used for UART. I'm going to not use this as a factory reset yet. I can always change any pin to be the factory reset pin if I end up using one. SDIO, SW clock, and reset cannot be changed. So these are fixed pins, but the rest of them I can change however I want. So let's make this IO2. So that's this pad. So this will via here and then come up. And then we're going to skip these 3. Go to IO3. I'm going to call this IO4, and I'm going to connect it from this LED. And I'll connect this LED later. So this is also going to get disconnected. Because again, I can just change. I can set it to be any pin later. So why do the work now? 2. Okay, SWO. I think it's okay if I have this be a GPIO pin and also SWO. And I think IO5 is fine. It's iffy. On the other hand, SWO, because it's an output only, might be good as an indicator pin. Because it's like you can use it for debug and also indicating. So maybe SWO will be the Bluetooth LED pin. So I'm going to leave that for now because it's, it's a hardware support. It's used for debug output. Maybe useful. Unsure how useful. Okay, so IO5, IO6, IO7, IO8, IO9, IO10, IO11, and then we've got the extra 2 pins over here, 86, 87, so I'm going to be able to call this, I can move the pins up and down, but I'll call this IO12 and IO13. So that is all these pads. Oh, I got to rename. I got to disconnect these. Hold on. Boop. So this is S clock, MOSI. Ooh, sneaky. That's an IO. Should be 3 volts. Actually, it should be bus. Miso MOSI S clock, but then this is going to be IO13, IO12, and IO11. Okay, so right now, the good news is we have set, I think, all of the GPIO. Let's see what the complaints are. Okay, so I don't have the LED 1 or LED 2. That's not the worst deal. PIO 7. Oh, you forgot about these outer pins here. I can actually, I'll make, I can make these. I forgot about these. This is the closest to IO 12, IO 13. And then I don't think I set SDA SCL, so I'll make this SDA. Oh no, I don't want to do that. I remember. 12, 13, so this I'll make this SDA. Now I remember. SDA, SCL. And then this is an extra pin, so I can use this for LED 2. Let's see how I'm doing here. Only input pins on TXD. I'll deal with that later. Only 1 pin on LED 1. Only 1 pin on RXD. Oh, right, because this has to be TXD, I think, is IO 0, and this is IO 1. Okay, only 1 pin on LED 1. VDD connected to VPAT, no big deal. VSS connected to ground, no big deal. Rigid is 3 volts. VDD is 3 volts. VIO is volts. Thermal pad is ground. This is, I'm going to call this V high, not VN. VN, this is actually a little bit of an issue. I got to decide what I'm going to do with this. Like, what does, now that I think of it, this VBAT should probably be, it has to be close to 5 volts. I think I'll call it V high. And then VN, I don't know what I'm going to connect it to. That's maybe V bus. This is a tough one because it's like I'm renaming pins. Like, what does it really mean? Like, what's VN when you don't have a DC power plug? Okay, so this is correct. That's fine. That's fine. That's fine. Oh, the switch. I gotta connect this to something. I can.
So my mic's off, but you can repeat the question back.
Yeah. What's the question?
So we had the idea for the product today. Started designing today. How long from idea until it hits the store?
It can take up to 2 or 3 months. It depends. Just because there's so many other things in motion at the same time. But I'll definitely try to have a prototype to try out within like a month, because it takes like a week or 2 to get PCBs, and then I have to hand assemble them. So this switch, I'm going to connect to the enable line, because that was my idea. I would still have this on-off switch here, but it would not be connected to, it wouldn't be connected to the DC jack. It would be connected to like the overall board, so it would power the board on and off. All right, so the good news is like, okay, I kind of got, well, yeah, oh God, polygons. I forgot. It doesn't like it when you do what I did. All right, I'll fix this polygon later. Okay, so the good news is actually, you know, there's a lot of wires, but they're quite nicely arranged. Thanks to those extra 2 pins that I forgot about, the ones that are tucked, they're underneath the module, which is a little unusual. These extra 2 pads, but there's no reason I can't use them. I just don't usually use them because they're not exposed. Like on the Feather, I didn't need them. But given that I have them, I'm going to use them. So I've got all the pads I need to have separate SPI, I2C. I've got the debug interface still. I've got that LED 1, LED 2. So LED 2 is blue, and that's like, you know, Bluetooth notification. LED 1 is actually the same as the pin 13 LED. So I'm actually going to change this to be IO 13, and then I'm going to delete this. I don't need this because I already have that LED in place. Bam. So that got rid of that other thing. This switch value is like, oh man, what's the name of this switch? It's like single pole, double throw, right angle. I don't remember the part number. These test points. So I use these for programming. They don't have a value, that's okay. Y1, this should be 32,768 kilohertz. And then this is fine. This has, oh, you know what, this is V-Bus. This should not be
Oh,
called.
here's a question.
Yeah.
Just repeat it back. Why do many people use hardware pull-down resistors when any MCU has internal pull-ups? Repeat it back.
So the question is, why does,
When people use hardware pull-down.
why do you use hardware pull-downs when they use, there's hardware pull-ups in most pins on microcontrollers? A lot of microcontrollers don't have pull-downs. They only have pull-ups, like AVRs and PICs. I don't remember the 8-bit ones ever having pull-downs. They only had pull-ups. So if you need a pull-down, you need a pull-down. I don't know, other than that, I mean, you know, if I can use an internal pull-up, I will always use one, because you can always disable it to save power. But probably just because the chip doesn't actually have pull downs. Also, like some people when they're starting out, they're very cautious, and so they add extra pull ups or pull downs, even though they're not necessary. So this is okay. Approve, no visual connection. Let's give this a name. Like this I need to pull up because there's no internal pull up on the APA 2112. So I have a pull up here to V high, but then to shut it down, I will crank it to ground through the switch. And that's kind of it. I mean, like, you know, I gotta do the rest of it, but
50 minutes.
yeah, I'm done. I'm gonna just rearrange this stuff, and then you know, tomorrow I'll probably route it, and that's the beginning of design. I still gotta think about where to put this module, but I think here's where I'm gonna keep it. I think it's a good spot. And then yeah, just like a lot of fun routing all these wires, lots of vias, and then just route them around, and we're good to go. We're good to fruit. Fruitin'.
Okay.
Do you have any wisdom?
No.
Good.
We're gonna make popcorn and watch RoboCop 3 because then you are caught up. I've forced
I'm being
Ladyada to watch RoboCop 1. RoboCop
This is my
2,
mistake. So
and now RoboCop 3.
I told Phil I haven't seen Top Gun
Where's
or RoboCop.
Kane?
And then it's like, not only was I saw RoboCop, which is like great, you know, I've seen this movie, but then it was like, it didn't end. He's like, well, now I have to watch RoboCop 2, and I'm like, well, I don't care about watching RoboCop 2. He's like, well, you have to.
You have to.
And then after RoboCop 2, which like we've made it through in 2 nights, like what's funny is like while you were watching RoboCop 2, I was like looking up data sheets for the NRF52, I was like, this is so boring.
Yeah.
But like thanks to the wonders of technology, he can watch a movie on the TV while I'm looking at data sheets and schematics. And then tonight's RoboCop 3, which is just going to be downhill. But there'll be popcorn.
Yeah. Okay, one last... sorry. My mic was off. Whoops. One last question. When working on designs like this, do you have design reviews with other engineers? Yeah, other 80 engineers that we have on staff.
I mean, K-Town's going to look at it.
Yeah.
Like,
we have like one or
because
two. We have one person look at it.
Yeah, K-Town and I like chat about, especially since he's got like Bluetooth expertise. So for example, if there are some pins that can't do certain functions, and I don't, you know, like it's like you'll always be able to find it in the data sheet. The data sheet might be like 250 pages long, and you may not look in the right location. So I'll definitely like have him look at this, and I'll say, look, is there any pin that I'm using that I shouldn't be using? He'll be like, oh, you know, PO25 is like a weird pin because it doesn't have a pull up or something, right? He'll tell me like this pin's not a good pin, or this pin can't be used for timers, or like this pin is, you know, whatever is special. I think I got all the special pins, but I'll make any adjustments as necessary.
Okay. All right, that's it for tonight.
Okay, so tomorrow, routing.
Yep. See you tomorrow, everybody.
Thanks, everybody.
Pick up something at the Adafruit store.
If you didn't hear what Phil said, he's going to make me watch RoboCop 3. I don't know if you could tell from my distressed rant.
I'm having trouble.
Yeah. It's funny. It's like he actually got paid to act robotic and wooden.
Yeah.
Good work. All right. Good night, everybody.
Bye.